Okay, Gary and Elga, you may start as soon as you are ready to present. Oh yeah, I have to allow you to share screen. Okay.
Elga mau gue yang share apa? Oh. Disconnected.
Keluar.
Iya, disconnect.
Okay, you may start as soon as you are ready.
Okay, good afternoon, Pak Dedi, Bu Lydia.
Yeah.
So today we're gonna continue about our discussion for our mechanical support for spinal muscular atrophy patients. As we only modify a little bit from our last discussion. So from last conclusion, we conclude that we don't we need to lower the height of the motor, and we also conclude that we will use 2 pulley and 1 motor there, and we're gonna divide the sleeve from 1 big sleeve to 2 small pieces of sleeve, and we also use the counterweight. So basically this is the we already modify a little bit from the last basic principle of the design. This is the picture how it's gonna move, and this is the sensor. Okay, so I'm gonna discuss a little bit for the sleeve design, but well, I already calculate a bit for the upper part of the sleeve. So because the diameter of the upper arm from the patient is 18.5 centimeters, I approximately will need the sleeve at around 20 centimeter and 2 centimeter for the Velcro, and we still use the same design, and this is the approximate design for the size for the sleeve. And then so this is the placement. So I gave a space for the patient from the upper sleeve to the elbow. It's around 4 centimeters. Oh no, not 4. It's around 6 centimeters. So then the upper arm can lift more easier. And I calculated the maximum degree for the angle for the rope. If approximately it's the distance from shoulder point to the upper arm sleeve middle point, it's around 16.5 centimeters. And the height from the shoulder point to the pulley point, it's 6 centimeters. But this is still a rough calculation because I still don't know the exact height for the pulley and the motor. So if it's around 6 centimeters, and then we can calculate the degrees using arc tangan. And then we found it in 20 degrees, and this is how we calculate the pulley stroke. So we know how much force that we need to pull the arm of the patient. And this part, Elga will explain.
This is the circuit, our plan for circuit diagram, and we use 2 buttons. So the first button is for move upwards of the arm, And then the second button is for the movement downward. And we use 4 relays here, and the two relays it's for upwards movement, and the second 2 relays for downward movement. And we use the motor here. And actually this is I got from this circuit I got from the reference. So uh, it it hasn't mentioned the pulley yet. So basically, so actually we have to uh, put the pulley after the motor, and we use uh, 6 external power source, and then we use Arduino. So next slide, please. So this is the component. Can you please stop your share here? Okay. So here's the motor that we want to use as a plan. Oh, we will use stepper. This one, the price is 120,000. It's a second. It's a second item, so it's not. It's the used one. The voltage that it used is 3.2 volt, and then we use this one. We use pulley, second system pulley, but actually we don't know yet how to systemize the pulley and the rope itself, because we don't know what pulley that's suitable for our project, um, for the arm, exoskeleton arm. And then this one, the module, relay module, we use the opto isolation ones, and then we use 4, and then Arduino Mega, and then push button we just use 2, and then battery we use 6, and then the total it's about 500,000 rupees. And yeah, okay, Gert, can you please go back to, I will stop my share and then go back to the presentation slide. Okay. And then for the next step, development, if the components already approved, and then we will buy it and install the components needed. Yeah. Thank you. Yeah, that's it. That's all for our
That's all.
presentation.
Okay. Yeah. Okay, Bolivia, you may ask question or you may suggest some inputs or
You
critics.
are using NEMA stepper. Is
Yes.
it what have you reduced? You have a gear reduction in it?
Sorry.
The motor that you are using is NEMA 23.
Yeah.
Is that include the gear inside gearing or?
Yeah, I think so. We haven't buy the motor yet, but when we try to look for it, that's the that's the motor that comes out. That pop. I mean, we tried to look for it in Tokopedia, and That's what we can find.
But what torque can it does it have? What
The exact torque we haven't found it yet, but we already asked the seller.
Here maybe.
Can you share the data sheet maybe? Can you
Okay.
share screen the data sheet of the motor?
No. What is your requirement and what is you think what is your requirement and what is the torque that is given by the motor?
So
Helga, Gary, can you answer the question? What if you calculated the required torque for your system?
for our system, can you please share our presentation again, Gary?
Just give the and do you know that the NEMA stepper needs to have a driver?
Yes.
Is that included?
This one. I think no, it's just for motor. So this one, so we found that the least of the degrees, 20 degrees, and then if we calculate the F, the force that we need is 287, and then if we use two pulley system and then we divided it by 2, and it's need like 180, and then if we use just one pulley, it will become 40 Newton meter. If we just use one pulley, and then if we assume that the radius is 0.05 meters. So if we use two pulley, then it divided by 2, and then I'm still loading for the data sheet.
Yes, I mean, it's you should check first before this presentation whether your torque requirement can be satisfied by that motor, isn't it? If it's too difficult, then don't need to check it. But I just want to make sure before you buy it, you make sure that it's have enough torque. Okay.
Yeah, but we still have kita masih agak ragu di bagian mau beli juga karena we don't know how to connect it with the pulley. Yang kita bisa pikirin cuman kita I think that that motor needs use a gear to move the pulley, but in the other hand pulley-nya itu kelihatannya nggak ada gear di dalamnya, so I don't think that it will move inside of it. Jadi yang saya bisa bayangin cuman bisa dilas gitu doang.
Yeah, there are several ways to connect a pulley to a motor. You can put the the motor inside,
Yep.
and then you can thread something to put the bolt in. That's one
Okay.
option. And then the second option, you can use keyways. You know keyways? Keyways like that. Because NEMA motor that you are supposed to purchase can have a flat surface, so it's not completely round. So that flat surface can be used so that it doesn't move together with, it doesn't move against the pulley. Okay. I think you should contact me more often about this.
Uh,
Yes, thing, yeah.
What is the torque capacity of the NEMA motor? That NEMA motor.
Yeah, that's what I was asking.
My internet is still it's still loading. I'm still here.
Gary, can you help?
Mechanical
Maybe Gary,
Yeah.
can you download the data sheet from the for that NEMA motor?
holding torque. Holding torque is 270 ohms.
270 watts. What's the unit of it?
Maybe you can share the screen, your screen, Elga.
Yeah.
So we can watch together. We can look together at the data sheet. Okay.
Okay. It doesn't have.
Only said high torque,
Yes.
but how high is high torque? Ah, that one.
I've tried to calculate it. I think it's around, for the holding torque,
That
around,
one.
189.
1.8, 1.9.
So 189 Newton centimeter, right?
Centimeter. Yes.
So in Newton meter, that will be
1.8, 1.9.
1.8.
1.8. And your calculation?
7 for 2 pulleys.
7 Newton meter.
No, I think 1 point something. 1.8 if we use 2 pulley, and if we use 1 pulley, it's 2.87, if I'm not mistaken.
No, we first, this is the data sheet. Your calculated required torque is how much from your presentation just now?
0.
Can you show again can you share screen again, the presentation?
0.14.
Just please share the screen. That's all. Much easier. You see, it's 14 Newton meter, right? You calculated then.
Yeah, in meters.
14 Newton meter. You have to say it completely Newton meter, not just in meter. So because this is torque, yeah, not length. So the data sheet said 189 Newton centimeter or
1.9.
1.9 Newton meter. So definitely it is not enough, right?
Yeah.
To hold this 14 Newton meter. So you will have the same problem again with the last year team.
Mm.
So you need stronger stronger
Motor.
torque, or otherwise, as we had suggested last week also from the previous week, you need a counterweight. Why didn't you put any counterweight in your design?
For me,
We put here. I mean back here.
Yes. Okay, have you calculated how much counterweight you require? So that the counterweight is basically to balance that the force on the other side of the pulley. So then the torque is not necessary to hold the weight of the arm, okay? Because the weight of the arm will be balanced by that counterweight. You get it? Do you understand?
Yeah.
yeah,
Yeah. Now you have
And
to
before
calculate
that,
that counterweight. So depends on the weight of the arm. You haven't put that into your calculation, right?
haven't.
you have to check what is the not only the maximum but also the minimum of the torque required. So you have a range there, minimum and a maximum, and then you can balance it with the counterweight, and then the rest can be done by the motor. Yeah.
Yes.
But you have to know what's the maximum and what's the minimum. The maximum is not enough. It means that if you are only using the maximum, then maybe the child will have difficulty of putting their hands down if the motor is not strong enough to bring the hands down, isn't it? Okay, I think you should work on it again before you suggest to buy something that's not going to work again. If you find out that your motor is not enough, I mean, you have to find some gearing option so that the gear can be used to get a mechanical advantage that can lift it. Although it's slower, it's okay. We don't have at the moment we don't have a restriction in the speed, you know. So in theory, you should be able to find a mechanism with motor that can bring the hands up. Even though it's slower, it's okay.
Yeah, I think the motor task is just to rotate, but not to hold the weight of the arm. That is what two of you need to understand. Yeah? The motor role is just to rotate, to actuate the rotation of the arm, but not to hold the weight of the arm. The role to hold the weight of the arm is conducted or is done by the counterweight. So you have to design also how should you put that counterweight? What will it be made of? It is from 20 kilogram, right? You measure there's no 20 kilogram in your calculation.
2.
So what will be that counterweight? Where will it be put in the wheel in the wheelchair? And also you need to put rope as well going to the pulley there and the pulley there will withhold the sleeve, yeah, with another rope. So try to make it your design more detailed using any three-dimensional design software, yeah, Tinkercad or whatever, or SolidWorks if you have the license for student. Yeah, so make it more detailed. Like now you have improved design compared to the first milestone, but still relatively rough design, right? But you have to put that counterweight to the calculation. So with that counterweight, you do not really need to have 14 Newton meter of torque, because that 14 Newton meter torque is necessary when you put the motor to hold the weight of the arm. That will be then similar to last year. That is the mistake of last year team, using the motor to hold the arm. Cannot, because the motor is too weak to do that, and they do not have also gearing mechanism. So the only way, the only one of the quickest way is to have counterweight. Okay, so please put that into your design. Make a more detailed arrangement design. How will it be put? So Ibu Lydia has sent to you, right? I have also put in the classroom, Google Classroom, the design of the wheelchair. Ya, Kurota or I forgot, something like that. So you can.
I think I've sent you the design of the back of the wheelchair.
Yes.
The full design. Have you received it? Okay.
Yeah.
Yeah.
Yeah. Yeah, I have.
Okay. Make it.
So make it more detailed, and then please send to Ibu Lydia for comment. Then as soon as approved, ready, then we can start the purchase of the motor, the pulley, the rope, the counterweight as well. Do not forget the counterweight.
Saya ada pertanyaan, Pak.
Yes.
So,
Yeah.
counterweight itu kita calculate atau we put the exact same amount as the weight of the arm?
Yang dipakai kan itu sebenarnya bukannya beratnya persis dari ininya, tapi di posisi-posisi yang berbeda, dia kan akan berbeda juga counterweight yang dibutuhkan, kan? Benar nggak?
Yeah.
So you have to calculate the minimum and the maximum of the torque required to lift the arm, and then you calculate the minimum and the maximum of the counterweight. After you get the minimum and the maximum, that range can be used by the motor. You understand? So the motor only offset what is the minimum and the maximum.
Yang tadi saya tangkap sebelumnya
It doesn't need to do the whole job.
So jadi movementnya benar-benar bergantung sama si counterweight, motor counterweight cuman untuk for the minimum requirements and the maximum requirements.
Beratnya itu ditanggung oleh counterweightnya, seperti lift elevator, you know.
Yeah.
When we go to the building, itu bukan oleh motornya itu yang menahan berat kita. Yang menahan berat kita adalah counterweight di sisi lain dari bangunan. Tapi untuk gerakin ke atas bawahnya itu motornya, jadi torque-nya tapi tidak. It doesn't depend anymore on the weight of the people yang di dalam lift gitu. Ya, jadi karena itu lebih ringan.
It's still
more energy.
It is still depend on the load itself. It is still depend on the load itself, because it can be different. For example, 10 people or 1 people, it should be different. But at least the weight of the whole things itself, it's not from zero. So you can you just offset the rest of it. Like in this arm, you put the counterweight so that it can lift the minimum weight can be lifted. But if you still need to lift it higher, then you ask the motor to do it for you. Otherwise, if you just put the counterweight without calculating the minimum and the maximum, then the hand will be lifted upwards and stuck there, isn't it? Then the child will need to bring it down again. Make a different scenario of how many degrees the arm moving and what is the counterweight required there. Then you will come up with minimum counterweight and maximum counterweight. Say, for example, minimum counterweight needed is like say A, and then the maximum is B. And then how do we change between A and B? That's the task of the motor, okay? Hello?
Yeah.
Halo.
You.
Ya, Bu.
Any other questions, Jerry?
Um, for me, is it like how do we know how do we use the appropriate pulley? Soalnya kita cari di apa namanya di Tokopedia itu kayak buat sangkar kan, buat narik sangkar gitu. Apakah itu sama atau berbeda ya?
Yeah, you mentioned that.
Selama itu bisa dipasang di motor.
Ya, selama bisa dipasang. Yang kedua juga, you mentioned in your calculation actually the diameter of the pulley also will play a role, right, on the torque. So if you have larger diameter, then smaller torque is required, right? But however, then it requires space in the placement in the wheelchair. So it is something which you need to optimize. If your pulley is too small, also
That's a good
it
one.
require a lot of torque to rotate. Yeah, to rotate. So something which you need to optimize. So try to look at the options there available in the market, how much pulley, and also look at the spatial constraint, the space constraint in the wheelchair design itself. Where are you going to put that? And if it is too large, also it will not be too feasible. It will not be too comfortable for the child.
Yeah, and I see in this design you do a complete abduction that way. Is it
Yes.
going to be functional that way?
Completely abduction condition.
Okay. Yeah. Okay. For this, we try that. It's not something that's functional. I think yesterday you mentioned that we will make it 45 degree.
Yes. So it's not
What makes you think?
yeah, so it's not really like make a space in the horizontal space of the child. So it will easier for the child to move the wheelchair.
Yeah. It's just that I think that is not many functional activities that can be done, but if the hands is like that. How about if you watch it from above, it shouldn't be completely straight like that. How about making it a bit to the center? Just make an angle of it. Okay.
Yang dimaksud angle itu tadi berarti jadi dia nggak
From
terlalu
the top.
lurus ya, Bu?
If you see from the top, it
jadi nggak 90 degrees antara. Kalau ini kan posisinya berarti 90 degrees.
Yeah. Can you watch me?
Yeah.
Yeah. I mean this space, not completely that size. You see? If you are doing like that, not many activities can be done here. Yeah, move it a little bit this way.
Little bit in front, then, Bu Lydia, yeah. About 45 degrees.
Yeah, but not exactly in front, but make it 45 degrees. Yeah, the same mechanism can be used.
Yeah.
Just
It's also easier to put counterweight.
Berarti yang diubah cuma placement dari si motor sama pulinya.
Yeah,
arahnya aja, arahnya.
Axisnya, you change the orientation of the axis of the rotation. Yeah, the motor axis.
The mechanism can still be same. Okay, and the counterweight is not a problem, isn't it? Because the counterweight will be in the back anyway.
Yeah,
Yes.
that's why I proposed to you last presentation to have a degrees.
Mm-hmm.
But because of
Yeah.
because of the picture only 2 dimensions, so so it's like this. But the real we will put the degrees a bit in front.
Okay. Yeah, can you draw it from the top? If you cannot draw it in 3D, that's fine. Learn about drawing in orthogonal projection. You draw it from the top, draw it from the sides, and draw it from the front. That's why that will make the viewer can understand what are you talking about. And also the size, you put something from the front and from the side. The length of the hand you draw is still seems like you're drawing from the hands is like that, because there's a force shortening, isn't it? If you put it like that, then this will look shorter from the back or from the front. Okay. You can just using a pencil and draw it from the top to make it easier for us.
Okay. And Gary, if possible, also find some possibilities, yeah, for the motors. Yeah, maybe try to find out other possibilities from different vendors. Maybe I think the NEMA is the one that is used by Andrew last year, right?
I don't know.
You don't know. You can ask him, because last year he used some motor as well, his team, but could not lift the arm completely. Also because they did not use counterweight as well, so that's the reason.
But actually, if we let's say if we have that kind of motor, and then can we just adjust the counterweight? So as you mentioned, that motor is just for to rotate the pulley, not to stay the arm or to move the arm directly. So I think if we have that kind of motor, and then we just adjust the counterweight, it will work.
Theoretically, yes. Theoretically, in paper, yes, but in reality, there are the weight of the counterweight as well as the arm will be put onto the rope, right? And the rope that weight of the rope will be put onto the pulley, right? That's why I was mentioning that if the pulley is large enough, then the torque to rotate it might not be that big. But if the pulley is too small, most of this will burden the motor also.
Okay.
Yeah. In theoretical statics that we learn in classroom, there should not be any friction, right? There should not be any friction between the pulley and the rope. Then yes, it is ideally like that. So then the counterweight will balance the weight of the arm. So then the motor can just rotate it. But in reality, there is friction. In reality, there is friction, and that friction need to be accounted also.
Okay.
Yeah, and also it's not constant, isn't it? It's not constant.
Yes, it's not constant. Also, it will depend on the speed as well, actually. But since we are not going to move it very
if
fast.
you put the whole body, if you put the whole body, the whole person, and you tie it up, and then you have a counterweight, you can have the exact weight. But in this case, the child is just part of the arm. So the load to lift it will depend on the position, because part of the load is bear by the body.
Yeah.
So you will not have an exact, even if you have a counterweight of a certain weight, it will not be the same in every position. In some position, it cannot lift it. That's what the motor will trying to do. And in some position, maybe it can be lifted too high. That's you have to consider that. And the range of the motor, the torque required, is depend on the discrepancies of the minimum and maximum of the torque required. If it cannot, let's say you need 2 or 3 Newton meters between the discrepancy, and the motor cannot accomplish that, then it will not be used, because the counterweight will either cannot lift it all when the motor, even together with the motor, or the counterweight is too much, then you lift it, it will stay up like that. Okay.
How to make the counterweight adjustable?
I just want you to have a good practice.
Yeah.
I just want you to have a good practice of calculating first, even before presenting this to us. Like just now, we had just found out that it won't work.
Yeah.
How about if we have bought it and it cannot be used again? Yeah, it will be a waste of time and money.
Okay, Elga, Gary.
If you are sure, then go ahead.
No more questions?
Okay.
Ibu Lydia, any other comments or critics for them? For the work?
No, I think they are freezing maybe the signal, or
in my screen it's okay. They are okay.
Okay.
Okay,
Then
no more.
so for now we end the discussion for now. Yeah. Okay.
Yeah. Okay. Thank you very much,
Thank
Ibu
you.
Lydia, and also Gary and Elga. So please put the comments into your next design. I have put this assignment for the second milestone in the Google Classroom. So please upload your PowerPoint today to the Google Classroom, yeah, for your to be marked, and just need to be submitted one, yeah, for 2 of you. So because you are working as a team. So for the next session for third milestone, we will be doing it in the next 2 weeks. Yeah, hopefully by the time your design is ready, try to make it nice, as Ibu Lydia mentioned, using orthogonal projection. So use some real 3D design software. Can be Tinkercad, SolidWorks, or anything. But if necessary, you may also consult with Ibu Lydia directly. You have her email, right? And you also have her phone as well. So do not hesitate to contact her. Also, maybe also to me, if you need some advice or suggestion. Yeah, but I think you already know. So you just need to find it out in the market, what is it, and also to calculate first and make a nice graph, yeah, nice graphic design of what you are going to make. So be sure what you are going to make before you purchase the components. So hopefully we finalize the design by 2 weeks from now. Then after that, then we can start building the device. Okay, thank you very much again to all of you, especially to Ibu Lydia for the time. Yeah. See you in 2 weeks from now, Ibu Lydia. Yeah. Thank you and bye-bye.
Yeah. Thank you, Bu Lydia. Thank you, Fadi.
Yeah. Well, I mean, if you need it, yeah. Okay. Bye.
Bye-bye.